visit scientists at Southwest Research Institute who are making a career of studying Titan. It's the largest moon of Saturn, and it's a true mystery of science unfolding for these curious investigators.
I got interested in Titan because we found out that the building blocks of Titan were very organic rich, more organic rich than we initially thought. And so I was interested in how those organics could have played a role in forming Titan's atmosphere. Titan is a satellite of Saturn. It's Saturn's largest moon, and it's the only moon in our solar system that has an appreciable atmosphere, and the only body in our solar system other than Earth that has liquid on its surface. And so it's a really interesting place for those reasons, and it also has a lot of really active organic chemistry going on it. And another way that we've learned a lot about Titan's atmosphere is with the Cassini mission. And so the Cassini mission was in the Saturnian system for over 10 years, and they passed through Titan's atmosphere, and they were able to measure it directly in that way. And there was also a probe that they landed on Titan. Titan's atmosphere, like Earth's atmosphere, is primarily nitrogen, and it has about 5% methane as well. And there's a lot of organic photochemistry that occurs there. So organic molecules that form via reactions with sunlight and then drift down to Titan's surface. And so the surface, as far as we can tell, is basically covered in organic molecules. Titan has potential to be habitable, but of course we haven't found life there, and there may not be life there. And so the molecules that we know of there are not created by life processes. They're created by other natural processes that don't involve life. But this core is heated enough that these organics are getting cooked, kind of like at a backyard barbecue, and you cook the charcoal and you produce some gases.
Here in the calibration lab at Southwest Research Institute, we're looking at an ion-neutral mass spectrometer. This is just like the one that was on board the Cassini spacecraft that was able to examine the atmosphere of Saturn's moon Titan and the atmosphere of Saturn itself.
I like to think of an ion-neutral mass spectrometer as like a sniffer. So it sniffs in the atmosphere, and then it tells us what the chemical makeup of that is.
So what happened is Cassini swooped down into the upper atmosphere of Titan and was able to sniff and sample some of these gases, and using this technology was able to find that argon, we had never known that argon was in Titan's atmosphere, was present, and we found out how much is there, and it also was able to determine the ratio of nitrogen isotopes. And by combining these data, we were able to have a new understanding of how Titan's atmosphere formed. A whole host of complex organic molecules, which may give us some clues to how organic compounds might form on the early Earth or in other places in the universe.
It tries to answer our question of where does life come from, where did our solar system form, and how did we get here, which I think is something that has been asked by all civilizations throughout time, basically.